This is example number 2 in our introduction to special systems. In the first two examples, you saw what happens when you have a parallel set of lines. You end up with no solution because the lines will never cross each other. In this example, I would like you to try to solve this system by elimination. Hit pause so you can try to solve it, and when you're ready, hit play so you can see the solution and explanation. The solution and explanation of this system is as follows. When you try to solve by elimination, you look at your system and you think, what do I need to multiply either equation by in order to create an opposite set of variables that will cancel out and eliminate the variable in the other equation. Looking at this pair, it looks like I can multiply the very first equation by positive 2. Make that negative 2. When I multiply by negative 2, I have the new equation, positive 4x minus 2y equals negative 6. When I rewrite the equation at the bottom, I have negative 4x plus 2y equals positive 6. In this situation, when I try to add these equations, I get 0 plus 0 equals 0. Whenever you have the situation where 0 equals 0 and your variables disappear altogether, it's because you have an infinite number of solutions. The reason they're infinite is I've actually got the same equation. Looking up at the top, I have 4x minus 2y equals negative 6. At the bottom, if I multiply by negative 1, let me show what that looks like here in green. Everything gets multiplied by negative 1. I now end up with 4x minus 2y equals negative 6. You have an identical set of equations. One is equal to the other. So when you graph one, you'll graph the other one exactly on top of it. They overlap each other. So every value of x and every value of y satisfies this system because they're the same line.